welcome to WiseKind. Today let's talk about repeated multiplication. What is repeated multiplication, you might ask? This is one of the most commonly missed concepts that your young learner is going to come across. So let's talk about it. Repeated multiplication is when we have a number being multiplied multiple times. So for example, 2 times 2 is equal to 4. This is repeated multiplication. Or we might have 3 times 3 times 3 times 3. And that happens to be equal to 81. That is an example of repeated multiplication. We're taking the same number and multiplying it by itself over and over and over again. So with repeated multiplication, we have a base number. In this case, let's do a base number of 5. It's a big number. It's a factor. It's a multiplication term. Any of these words right here are used to represent this number. So we've got a base number, a factor, a multiplication term. Then we have a power. Let's put 4 up here. So that is our power or our exponent. And this is the exponential form of repeated multiplication. So we have a big number, that's our base number, it's our factor, it's our multiplication term, and then we have our power or our exponent. What it isn't, let's take that example. We have 5 to the 4th power again. It is not 5 times 4. This is a big no, no, no. When you are working with repeated multiplication, exponents, powers, you will never ever be writing the power number. So the actual power, the number of the power is never written. The number of the power is never written. So 5 to the 4th will never be 5 times 4. 5 to the 4th will always be a 5 4 times. So 5 times 5 times 5 times 5. So we never write the number 4. We just have 5 written down 4 times. So it's best for you to get into the habit of writing the base number, the big number, out the same number of times as the power. Get into the habit of writing the base number the same number of times as the power. Let's do another example to really solidify this idea. So we're going to write the base number the same number of times as the power. So let's say we have 3 to the 5th power. So our base number is our big number. This is our factor or our multiplication term. This is 3, 3, 3, 3, 3. It's repeated multiplication. We have multiplication between. So 3 times 3 times 3 times 3 times 3. That 5 will never show up when you're writing it out. So that's a super common misconception, mistake that happens all the time. All right, so let's talk about some rules that are pretty handy to know. 1 to any power. Let's say we have 1 to the 8th power. This is 1. How about 1 cubed? This is 1. How about 1 to the 10th? This is 1. So this is always going to be 1 times 1 times 1 times 1 times 1 times 1. 1, 2, 3, 4, 5. That's 1 to the 5th, and it is 1. So 1 to any power is 1. That's a nice thing to keep in mind when we're going through this. Another really common rule that is often misunderstood is the 0 power. So anything raised to a 0 power, let's say we have 8 to the 0 power, that is 1. So in math, we do this lazy thing where there's always 1s. They're always invisible. We tend to treat 1s like you can't see them. They're incredibly underrated and underwritten. But if we were to write 8 to the 0 power, really it's 1 times 8 to the 0 power. And this is telling us we don't have any zeros. This term is not here. But we do always have that 1, so we still get a 1. So if we have 1 to the 0 power, that's 1. If we have 3 to the 0 power, that's 1. If we have negative 10 to the 0 power, as long as that negative is in the parentheses, that's 1. The only time this 0 power doesn't work is 0 to the 0 power. This does not work. This does not equal 1. Okay, so the 0 power is cool. Even if it's a variable, if we have x to the 0 power, still 1. If we have d to the 0 power, still 1. So anything to the 0 power except 0 is 1. But you might be familiar with exponential form because you've done things or talked about things like x squared This is squaring. And when we're squaring, we're really doing x times x. We use this for finding the area of a square or rectangle. And you might even be familiar with cubing. So we have, let's say, y cubed. This is cubing. Or you maybe have talked about volume and you've had something like 17 inches cubed. So it'd be like with volume, you've done cubing things. And of course, y cubed looks like y times y times y. Again, that power 3 never shows up as a written number. Okay, let's do a couple examples with our exponential form. First example, let's write 8 times 8 times 8 times 8 times 8 in exponential form. Now remember, exponential form looks like some base to some power. So we'll have a little number for our power, a big number for our base. Our base is the factor or the multiplication term, in this case an 8. And then we count how many times we're multiplying it. 1, 2, 3, 4, 5. So our power is 5. So 8 times 8 times 8 times 8 times 8 is 8 to the 5th. And as you can tell from that example, it's very nice to use exponential form. It takes less writing and it also is quicker to say. Let's do another example. So let's take 3 to the 4th and we're going to write 3 to the 4th in expanded form. So 3 to the 4th is already in exponential form. And we want to go to expanded form, which is like the 8 times 8 times 8 times 8 times 8. 3 to the 4th, our base, our multiplication term, our factor is 3. And then the 4 tells us that we're multiplying the 3 by itself 4 times. So 3 times 3 times 3 times 3. So 3 to the 4th in expanded form is 3 times 3 times 3 times 3. Last one, let's do one using digits. This is an interesting way to ask this question, and it probably wouldn't, I don't know, you might see it this way. So let's write 4 cubed with digits only. You might also see this as simplify 4 cubed. The goal is to actually perform the math of multiplying this out. So 4 cubed is 4 times 4 times 4. I'm going to look at this and see 4 times 4 is 16, and then I still have a 4, and then 16 times 4 is 64. Of course, we can use a calculator for this, but it's important to understand what 4 cubed represents, so we're making accurate estimations with our answers before we pop it into our calculator and get something like 216. Because then you can say, oh, I think I typed something in wrong, that feels too big. Express 3 to the 4th as a product of the same factor, then find its value. So there's a lot of words here, and we're going to think about what does it mean to have a product? A product means multiplication. And then the same factor, we remember that our base number is our factor. So 3 is our factor. So we're going to express this as a product of 3's and then find its value. So 3 to the 4th means 3 times 3 times 3 times 3. So there we have expressed it as a product of the same factor. Now we can think of this a couple of ways. I like to think of this one with little imaginary parentheses for my brain. And I'm going to think about 3 times 3 times 3 times 3. So 3 times 3 is 9 times 3 times 3 is 9. So I'm really doing 9 times 9. So 3 to the 4th is 81. Okay, let's expand 7 cubed times 10 to the 5th. So expand means that we don't want to write it in exponential form. We want it in expanded form. So this is going to be equal to 7 cubed means 7 times 7 times 7. And then 10 to the 5th means 10 times 10 times 10 times 10 times 10. So we just write each exponential term in its expanded form, and there's multiplication between them. All right, we could also multiply that together if we wanted to, but we're going to pop that into our calculator. Or we can do 7 times 7 is 49. Times 7 and then times 10 to the 5th. 10 to the 5th means, or 10 times 10 times 10, we have a 1 and then we have 1, 2, 3, 4, 5 zeros. So 1, 2, 3, 4, 5 zeros. So 49 times 7 times 100,000. 49 times 7, I'm going to think about as 50 times 7. Obviously, you can always use a calculator. But if I'm trying to just do something in my head to show off or to practice my math skills, I think about 50 times 7. 50 times 7 is 350. But that's 7 too many because I went 1 over 7 times. So instead of doing 49 times 7, I did 50 times 7. So 50 times 7 is like 50 minus 1 times 7. So what I did is 50 times 7 is 350, but then I have this, I was 1 over 7 times, so I really need to subtract 7 here. So 50 times 7 is really 343. So I have 343 times 100,000. I love multiplying with just zeros because all we do is tack them on to the end of our number. So we have 3, 4, 3, and then 1, 2, 3, 4, 5 zeros. And I'm going to add my parentheses so I can read this. So 34,300,000.